Okay, this is such a great lesson. So this takes all of those tests that we have in our calculator and kind of breaks it out, and then we're going to practice which ones do we use for what. So let's break this out. So we have z-test and t-test. These are the first two in the calculator. So this z-test is a one sample z-test for means, and that's the important part. This is the one that's for means. Now remember, we use the z-test when we know the population standard deviation. So this is not a very popular one. You're not going to use this very often. So the t-test is our one sample t-test for means. And this is the one that you're probably going to use the most often when you're doing a one sample. Okay, then we have the two sample z-test and the two sample t-test. So these are both used when we have two samples. And again, this is going to be the one that you're going to use the most often, the t-test. So two sample tests for means. Okay, so this is all the stuff that we've done in this unit. Now, these next two right here, these are our prop. And so one prop z-test and one prop and two prop z-test. This is for our proportions. So this is when we use it for proportions, and these are significance tests. And we know this because it says test. Okay? And then we have a z interval and a t interval. So this is a one sample z interval for means, and then a one sample t interval for means. And again, we're going to use the t interval most often. Okay, and then we have two sample z interval and two sample t interval. So this is our two sample tests. Sorry, not tests. These are two sample intervals for means. Okay, so up here at the top, we see z-test, two sample tests. All of this are our tests for means. And then we have our proportions, our one prop z-test and our two prop z-test. So those are our proportion significance tests. And then we get into the confidence intervals. So we have z and t interval, which is for means. And remember, we're going to use this t interval more often. And then the two sample intervals for means. All right, the next two that we have here are the one prop z interval and two prop. And again, this tells us proportions. And these are our confidence intervals. Okay, now I'm going to show you a couple of other things that are on here. So we have this x squared test and x squared goodness of fit test. And these are both our chi-squared, which is going to be Unit 8. And then we have down here this lin-reg test and lin-reg interval, and this is going to be for linear regression, which is Unit 9. Okay, so basically everything that we've done this semester we've got on our calculator here. So just a few things. So there are 8 total inference options. And remember, inference is what we're doing with a confidence interval or significance test. So inference, when you see that word inference, just think confidence interval, significance test. So there's 8 total options for means on your calculator. For each inference method, you can use the data that you've entered into your list, or you can use the statistics that are given. So the data that you have entered into your list, this is where we put the data into L1 or L2. Okay? Or if it gives you the information that you need, like it gives you your proportion or your mean, you can just stick that in as a stat. Okay, because the Z inference procedures for means involve unique circumstances where you have to know sigma, we will most likely not use these. So what this is saying is the Z inference for means, so that would be your Z test up here, or your, where's our other one here? Oh, Z interval. Those are probably the two that you're not going to use the most. Okay, now, super important. Special note for two sample inference means. We do not pool for means, all right? So we do pool for confidence intervals. Now, for confidence intervals, remember we calculate this p hat of our combined thing, and this is on your formula sheet, x1 plus x2 over n1 plus n2. You should know this one right now. But this is for confidence intervals. We do not pool for means. So you're going to see this on your calculator. It's going to ask you, do you want to pool? And if it's for means, we always say no. Okay, last thing. When you run your significance test, your calculator will get you an exact value for your degrees of freedom. And this value is going to be a decimal, and it's going to be very different than whatever you do when you have your, let me just write this down, different than n minus 1. So depending on how we calculate, if you're doing it manually and you list it like this, n minus 1, this is going to give you a whole number, and you're going to do manual calculations. If you use the exact value from your calculator, you have to report your degrees of freedom as a decimal. Okay, so let's look and see what this looks like here as we go through these different samples. So this first one that we have is a one sample t interval for means. So the t interval. So what is our formula when we do this? So when we have an interval, so confidence interval, this is where we have our critical value, which is going to be our x bar, our point estimate, which is our x bar, plus or minus our critical value, which is t, times our standard error. And our standard error is going to be s over the square root of n. And so this is where our standard error, so this is t times this guy. Let me just write this whole thing down. So this is the formula that I would do if I do this manually, all right? Now, when we do this on the calculator and we use t interval, if we use stats, this is the data that you're going to want to plug in. Your x bar, which is this one, your s of x, and your number. Now, a lot of times you can get this doing a one vars, your one vars setup, or it could be from the problem. Okay, and then when you run this on your calculator, this is your output, so this is your interval, and what you notice is that no t-star is given. So unfortunately, you can't just run this and get your t-star if you want to work backwards. So you have to do this the long way if you need to do this. And to get this t-star value here, you use inverse t, just like we used inverse norm to get our z. Okay? All right, so our next one is a two sample t interval for means. And this is very similar. The only difference is we have x bar 1 minus x bar 2. So this is my two sample difference, which is right here. And then I have plus or minus t, and then I have my standard error. So times my standard error. So your standard error on this guy is going to be your first standard deviation over your sample size plus your second standard deviation squared over your sample size. Okay, so if you plug in all your data here, you can run one vars to get this data, or if it gives you the sample and the sample set, you can plug in your data from here too. Remember, we always say that our pooled population here is going to be no, always, always. And then what we're looking for is we have this, we're looking for our degrees of freedom. So the degrees of freedom right here goes back to this answer. So if we have this p-value, so here's my, as I calculate this, if I give this value of negative 3.958 to negative 2.042, I have to list my degrees of freedom as 47.686. If I was to go over here and do it this way, I would list degrees of freedom on this one. I have sample size of 35 and a sample size of 40, so my degrees of freedom here would be 34. The smallest one minus 1. So if you calculate it manually, you would use a degrees of freedom 34. if you calculate it in the calculator, you have to use your degrees of freedom that's given, which is going to be your decimal number. And you see it's significantly different. Okay, next one is a one sample t-test. And y'all, this little chart does not have anything with z-test because you're probably not going to see it. So one sample t-test. What do I know here? So my critical value here, which is t, comes from my x bar minus our mean over the standard deviation of s over the square root of n. So here's my calculation for t. So when you run your t-test, you'll have your values that you have here. So your null hypothesis value comes in, whatever your values are, whether it's unequals, less than, or greater than. So remember, for the t-test, you're going to have your h sub 0 and your h sub a. Up here we were dealing with intervals. So with intervals, we're given an interval as an answer. Down here, what we're looking for is we're looking for this p-value right here. So this p is going to be our p-value. And what we have here with this p-value, and actually this doesn't have this here, but my degrees of freedom on this guy is going to be 34 because it's one less. So what we're reporting when we report for a t-test is we're reporting the p-value, and then once we do this, we compare the p-value to the significance level, which is our alpha. So we're not comparing anything up here. We're just giving the confidence interval. So now we're doing the test. So when we're testing, we're trying to figure out which one of these we're going to accept or reject or fail to reject. And when I have a two sample, again, this doesn't change very much. What happens is I have x bar 2 minus x bar 1, and then now my standard deviation is of both samples. Okay, and again, what we've got here is this gives this degrees of freedom. So if I use this value, so if I have this p-value, I have to report my degrees of freedom from my calculator. So use your calculator. Now, if you're using this and you use TCDF, which would be the manual calculation, so if I'm going to use this, right, and get my t-value and plug this in and use TCDF manually, then I'll use my degrees of freedom of 34. So I would use my whole number calculation again. So it's super important if you're doing it manually, use degrees of freedom. If you're doing it from your calculator, you have to report the degrees of freedom with a decimal. Okay? All right, so where we're going next is super important. So this is everything that we've done and how it all kind of comes together. So when you're trying to figure out which one of all of these tests to work through, we want to ask ourselves these questions. So what is this inference about? So what type of test do we have? So do we have something that's means, or do we have something that's proportions? So means, anything that we have here, we are normally going to use our t-value because it's more common. So when we have means, we have quantitative data. So you'll have something with a unit on there like milligrams or days or feet. So it's quantitative data. When we have proportions, let's go this direction first. When we have proportions that are on here, we're always going to use our z-value. So once you've identified that it's a proportion, you have to ask yourself, is it one group or two groups? If it's one group, you're going to want to run either a one prop z interval or a one prop z test. If it's two groups, and we've checked for independence, you'll run a two prop z interval or a two prop z test. Okay? Now, with means, it's a little bit different. So with means, we go up this direction, and we have one or two groups. If it's one group, we run a t interval or a t test. Now, if you look back at what we have on this, we can say a one sample t interval for means. But on your calculator, you're just going to see this as t int, t interval. That's what you're going to see on your calculator. Same thing down here. So a one sample t-test for means is just t-test. So when we see this, you can write the whole thing. You can say one sample t-interval for means, or one sample t-test for means, but just know that we don't have this one prop z interval. It's much shorter, and these are both for means. Okay, if it's two samples, we have a two sample t-interval, two sample t-test. All right, and then the one that's a little bit different for means is when we have matched pairs, and this is going to happen with an experiment. And what we'll do is a paired t-interval or a paired t-test. Now, these are not on your calculator, so with these, you're going to go back up and you're going to use that these calculator steps. So a paired t-interval, we're using just regular t-interval, and a paired t-test is just a t-test. So we're going to combine our data so that we can have one data set that we'll put in. Okay, so let's practice here. What we're going to do, these are all of the different tests that we've talked about, so proportions and means, and we're going to figure out what is what, like which one do you use. So we're going to decode this a little bit, and I'm going to do a few of these, couple of these to decode them, and then I want you to try this. So researchers want to estimate the difference in average systolic blood pressure between men and women and provide a 95% confidence interval for this difference. So I'm going to highlight the important things here. So the difference in average blood pressure between men and women and provide a 95% confidence interval. So here's what we have. Average blood pressure. So average, first of all, tells me that this is a mean, but this is also quantitative. So your blood pressure is quantitative. So because of this, I know it's a mean because it's average, but it's quantitative because it's a blood pressure. Between men and women, so I have two groups. And provide a 95% confidence interval. So hopefully you see right away that this is an interval. So what I have is means, two samples, and interval. So that is going to be a two sample t interval. T, this because it's means. All right, so this one's going to be D. All right, a survey wants to estimate the proportion of customers who are satisfied with their service and provide a 95% confidence interval. Surveyor wants to estimate the proportion of customers. So this is a prop, it's a proportion of customers. I have one sample set, and this is a confidence interval. So this is a one prop Z interval. So if I go up here and I find one prop Z interval, this is going to be H. Okay, let me go over and do, let's do this fitness coach. Let's do this top one. I'm going to bust around a little bit. A fitness coach wants to determine if a new training program significantly changes the running times of athletes by comparing their times before and after the program. So what we're measuring here is we're measuring just an athlete, and they're going to do before and after. So this is the same subject. Okay, and what he wants to do is a fitness coach wants to determine if a program significantly changes. So what we're doing is we're measuring this. And what are we measuring? We're measuring running times. Running times are means. They're quantitative. So I have a significance test. I know that I have a mean, and I have this athlete by comparing before and after times of the same subject. So this is actually a matched pairs. This is a matched pairs test for means. So if I go back over here to my examples, I am going to have a paired t-test. T, again, because it's means. So I go back over here, a matched pairs t-test, that was E. Okay, let's do one more. Let's do, a teacher wants to know if the average test score, so average test score, this should pop out right away as a mean, of her class is different from the national average of 75. So what happens here is we know that this is one sample, which is her class. So this is a one group. She wants to know if it's different from the national average. So what we're doing here is we're doing a test. And we're doing a test because we have this null hypothesis that's the national average, and we want to know if it's different. So my alternative hypothesis would be that it is not equal to 75. All right? So what I have here is a one sample t-test. So one sample, t because it's means, test. So that one's going to be A. Okay, I'm going to pause this and do the rest of these, and then go ahead and come back on and check your answers. Flip it back over and start on the other side. Okay, here's the first side, and here's the second side. All right, come see me if you've got questions on this.